Hey guys, how's everything going? This is JSer who is not good at algorithms. In this video, I'm going to take a look at 767 Reorganize string. We're given a string, check if the letters can be rearranged so that two characters that are adjacent to each other are not the same. Okay? If possible, output any possible result. If not, return the empty string. So like AAB, we could put B in the middle and ABA. And as AAB, so if we could only put one B among these A or these A, so either way, two adjacent A will occur, so it's empty. Well, the naive idea is something like bubble sort, right? We loop through the string from left to right, and if we found adjacent string, we need to find a letter that is not this A and insert into it, right? So for a case like this, we go to this A and find these double A are same, so we insert this B in it, right? And then we can go to next letter. And for this case, we insert B into here, and we move to this A and find there's nothing we can insert. So we fail, so we return empty, right? Cool. Let's try to do it. So first we will split split into array and swap when found adjacent same letters. So for let I row because we compare the previous one, so start from 1. If it's the same as previous one, we need to swap, right? Swap what? Swap the next letters, which is not itself, right? So we need to do it with the k equals I plus 1. K is more than characters dot end. If we need to swap k I, right? But if we cannot swap, then we need to return false, return empty. So we need we need to keep a flag, right? Let is swapped equals false. If we found it, we swap it, and is swap set to true. If it is not swapped, if we should swap but it is not swapped, we'll return empty, right? It's false. And at last we return characters join. So now let's implement this swap method. It's pretty simple. So it's done. Let's run the code. Cool. We got AAB. We insert this B into A, ABA. Yeah. Let's see if AAB work. Cool. Let's submit. Uh-oh. We got wrong answer. BAABA. It should be it should be reorganizable, but we return empty. Why? Okay, BAA, we met this A, and then we insert B, right? So there are two A left. There are two A left, but there is no more string, so we return false. But actually, we could insert this B. So there is a case. So actually, our assumption is not good. Like we met like this string, we rather than we do BAA, what we should do is actually ABABA, right? So rather than picking a letter from right, we should do something from left. But what if but what if it's if we do the swap, it's wanna be, if we do swap, it would be ABABBA. Oh no, ABABA. Oh no, swap with the second A, so ABBA. Which, how should we solve this problem? What's the problem? What if just we search from left? If we search from left, it will be ABA, right? And then okay, and then if we go to B, and we will swap A again. It's not gonna work. So what's the problem? The problem is that when we were searched, the possibilities of the letters like align the to left part are not used, right? That's the problem. So what if we reorganize again from right? Like for AABAB, we can now we'll go to ABA. Oh no, BA ABA, and then we got ABABA, right? Looks like we could do two rounds of swapping. Wow. Okay, let's do it. So I cannot find the evidence that why this should work. Just like let's assume that there is something case like we could use the letters of the latter one. 2. Yeah. So suppose we do it one round and find some letters that could not be swapped anymore. There must be, but it could be, there must be some letters could be used to how to say separate the adjacent numbers, right? Letters, right? So we could do one more round from right. So it will definitely solve the problem. If we cannot solve, then return empty, right? Yeah, let's do it. So we go one round. Rather than we return is not swapped, we should do break, right? And the flag is reorganizable. Reorganize, right? Reorganize, yeah. True. If it is not swap, we break, but we set to false, right? And then if recognizable, we just return. If not, we will do this again in another direction. So it's recognizable false, and then we set it, well, the code becomes very ugly. We set true. We set true, and then I should be count .length -2 bigger than -1 minus if I equals I plus 1 swapped k equals I minus 1. Yeah, and then we swap it. Okay, swap, recognizable. And then we check it again. In the case, we return empty. So this should work, right? Let's try. The error case would be BAA. Truer is not defined. Truer. Oh, there's no truer. This is true. Cool. Actually, yay! We are accepted. And let's try to analyze the time and space complexity, okay? We traverse through all the letters, and then the rest letters, we find one. The worst case is that we won't find one, right? We won't find one, then we return. So the worst case, other than that, would be get the letters in the last letter, and then we can continue this for loop, right? So generally, it should be O to square space, well, linear time, right? We will do this 2 times, so 2. So it's a quadratic. Okay, could we do better? Could we do better? Let's analyze the input. We're told that the S will consist of lowercase only, so it's finite cases, right? Have length in range like 500? Well, finite. And so one characteristic of this problem is that actually the original order doesn't matter, right? Because we can reorganize them as we want. Like for this input, this input for us actually is the same as AAA BB, right? If we have something like this, we could know that like there's a drawer theory. Like we have 2 drawers, like 3 letters. We must have at least 2 letters that are different from A, right? For B, this definitely not gonna work because there at least needs 2. So if I have BB, we can insert B and B in here, right? Cool. If there's not a B, yeah, like it could be here. If it is BC, still we could put it here. And this actually would generate more place where we can put numbers, right? If you have 3 C's, any new numbers will not break the spaces. So no matter what the letters are, we could definitely put them in it. If the amount of them is smaller, right? But A, if we say that A has the most occurrence, so the B, C will not surpass them. At most, it will be equal to the count of A, like 3 B's. We could put it like this. For C, yeah, we can put as we want, like C here, C here, C here, right? So it is obvious to us that we could just count all the letters and then find the biggest one, find the most letters, and the second to it. If they are valid, we could just collect them one by one, right? Collect the ABC, yeah. Cool. So let's try to do that. But first, we need to count them. So we create the count, new array, 26. And then we need to find the max and the second, right? Max and the next one. So we'll create an array called top 2. This top 2, I think we will just how should we get top 2? We could use quick select. So eventually will be log in. Or we can just sort them. We don't need to sort them. Okay, we can just use linear time. Yeah, let me use linear time to find the topmost. All right. Cool. Top 2. Okay, let's do the count. Code for A. Lowercase letters, so character code at 0. Counts. We fill them with 0. Counts S character code at I minus code for A plus equals 1. So this will get all the counts. And now we find the top 2, right? Let's say it's 0, 0. For let count of counts this one is the largest one. If count is bigger or equal to top 2, 0, top 2 shift unshift. Top 2 unshift count. And then top 2 pop, right? We put it in the first position. And if not, if it is bigger or equal to, equal is not, okay, we just put it if it's bigger than top 2 1. We set top 2 1 equals top 1 equals count. So now we get top 2, right? Top 2 count. Now, as we said, if top 2 1 is smaller than what? Smaller than top 2 0 minus 1. For 3 A's, there must be, oh, it's not top 2. It should be the sum of all the extra sum of all the extra string. No. Sum of all the rest characters. So actually, we don't need top 2. My bad. We only need top count. So top count equals mathmax. Mathmax actually we accept array, right? Allow me to use console max 1 2 3. Not a number. Oh, we can use spread 3. Okay, let's use spread. Max counts. Cool. Now this is top count. The rest would be s.length minus top count. If it is smaller than, what? Smaller than the top count minus 1, then it is invalid. We return empty. For the other cases, it will be cool. So how would we collect the rest, right? Collect the result. What if it is AAA, BC? Of course, we need it to be A, B, A, C, A, right? So actually, we just create the bucket and assign the rest to them, right? How would that be? How would that be sufficient? How would that be efficient? How would that be sufficient? How would that be? How would that be? Okay, I'll just create the bucket. Const bucket equals new array. Top count minus 1. And then push the rest characters into bucket one by one, right? So let I equals 0, let j equals 0, while I is smaller than 26. Okay, for I, and if we need to also not only keep the count, but need also to keep the character, to know the character, right? Yeah, so this is not good. let most letter be undefined. For let count let I if counts I is bigger than most count, most counts equals counts I, most letter equals string character from string from character code I plus code for A. So we get the most letter and most count. If most count. Okay. While we loop through all the character, the most letter. I think I'll just set the code. Store the code. That's enough. Code for it. Okay, if I plus equals most letter code, then we could just continue, right? If not the most one, let bucket index equals 0. So this one will be the bucket, the first bucket. Then let count equals counts I. So this will be this count of letters of specific letter code, right? Const letter will be the string from character code I plus code for A. We cache it with code. Okay, and then we will while count is bigger than 0. Yeah, count. While there's still letters, we put them into the bucket, right? Buckets, bucket index, current bucket. A push letter, and then move to the next bucket would be +1 mod by buckets net. Move to next bucket and then push it, and then we have all the buckets. So finally return new array most count field const most letter equals most letter code. we feed it with smooth letter, and no, we'll do it naively. Result must be most letter for let bucket of buckets result plus equals bucket join this, right? And then we plus most letter. Return result. So I think we've done. Let's take a look. Of course, invalid array length. Most count. Most count 0, most counts I. Huh? Invalid array length. What's the most count? Zero. What? BA. Code character 0A, so okay. Character code for A, okay. Counts. This is right? 0. Oh, length. Shit. Oh, I plus equals 1. Shit. There seems to be some there seems to be some infinite loop. It's 3, 0, 0. So all 0. Why? Why we start with 3? We continue. My god. Continue, but we forgot to plus I. So, miserable mistake. Still, we got 3. 1. Push of undefined. Current bucket 0. New array 3 and 1, right? Code equals this. We continue, so we need to current bucket 0 undefined. 2, right? We should not use. I see. this is not array of elements, but array of array. So we map field, map, oh yeah. And then we get BB like 26B. Okay. Remove the console. Cool. Now let's submit. Huh. We got BBB, but no AA. We got 2 buckets, right? 2 buckets, and actually we will insert A into it. Yeah, 2 buckets. And then check letter with count. We see, because B, A, where is A? Where is A, man? A from 2. Huh? I plus equals 1. Zero. Huh? While this, I'm a little confused. Ah, I see. Because when this is called, I is already set to 1. Oh shit. I will say, if it's not, and then I will put the logic here, and then finally I will plus 1. This should work, right? Yeah. Forgive me. I'm stupid. Submit. Still not right. Push of undefined like this. I see. Actually, this is not. If there is only 1, there's no need to put the bucket here. If all are different, wow. If most count equals 1, we just return S. There's no need to do the check. Let's submit. Why? Okay. EQ. Let's log the account and bucket. Console log. Buckets. Console log letter count. A0. Buckets I plus 1. There will be only 1 bucket, so we will just push into this bucket the most letters. Most letter would be G. Most letter code. E. E have 2. G has 2. Oh, I see. So the bucket should be should be a 3 bucket. Right? Yeah, it's not -1, but it's itself with the extra bucket at the end. And then when we map, actually, it would be something like this. Yeah. Well, this approach seems too complicated. Cool. Finally, we're accepted. Now let's try to see the time complexity. First, this will be linear, linear, linear. This would be 26, so linear, constant. But for here, we actually checked all the letters, right? The count. So linear. This, the bucket, linear. Yeah, so it's actually linear time and the space. We use a count array and a bucket, which the bucket will hold linear, right? So the account array will be 26 constant plus the buckets would be linear time, linear. So space would also be, at last will be another linear time, so it's linear. We have improved the performance of improved our solution from quadratic to linear time. Good. Sort by count. So let's see the solution. If any, ooh, this is very short. What? It's natural to write with some letter. For now, assembly is possible. Sort the string. Okay. Sort all kind of letters occur in a continuous block. Write in the following 3. The adjacent letters never touch. Exception to this rule is then n is odd. Huh? I think we're trying like this, right? Find the account of each character. Yeah, we do. Use it to sort the string by count. Okay. Interleave the characters. Count. Cool. Sort. Yeah. Then for each code, +2. What is this guy doing? Why is it only 24 lines? Why we use what? Why we use 50? Oh no, not 50. Here, 78, 59. Just twice as the amount. Well, what does he do? Character, we generate a new answer, okay, for t for each codes. Count, okay, okay, for n. What is n? Then if t, what is t? T plus 2. T equals 1. We get the character. If it is bigger than this, we return yeah, sure. Then we loop through all the code. Huh? I don't understand what does. I don't understand what this means. Oh, let's see. N is the nth, right? Counts. Okay. So it's loop through all the characters. Count it. Cool. Until here, we're actually doing the same. Now, but it had sort. Okay, we didn't do that. And then we created the end result array. Start from 1 for each count. We get the character, okay. If count is this, yes, and for each letter, we put, I see. Rather than we create buckets, rather than we create the bucket, actually he will, this solution just to put each character into the bucket, like into the right position, just separate by 1, right? Yeah. T plus 2, right? We put it there. And this will say if 2 is bigger, then set it to 0. Well, actually, we are doing the same, but much complicated. I'll rewrite here. I'll rewrite this. Now, collect the result. Wow, this is, I think this is genius. Constant result equals this. Okay, let's say let current position equals 0, let's say. And this will be, wow, this is much easier, yeah. Let's say array s.length for each count, right? For let count of counts. But we need to sort. Yeah, this actually depends on the sort. Uh-oh. Okay, then we first put the biggest one. First put the most letter. Most count, right? Okay, so for let I 0 as more than lowest count I++. Result, current position, we start with 0. Current position equals const most letter equals string from character code, like this. Set it to most letter. I plus, oh no, correct position plus equals 1, right? Sure. And now for the rest, right? If for let I const.length letter equals if counts I continue. Letter equals the I code for A plus code for A plus I, right? String from character code for A. This is letter. For each this kind of letter, we will let j equals counts I. While j is bigger than 0, we will push it, right? And of course, we need to check this. So if it is bigger than s.length minus 1, it should be set to 1. We start out at 0 with the even, right? Even positions. Now we set it to odd positions. Oh, plus 2, my bad. And we set it with letter, and then we plus 2. And then finally, we return result joy. Wow, this is genius. J minus 1. We get EVE, YE, PE, QG. Accepted. VY 4E. Why we get 4E? The most count. My bad. Or I plus code 4A equals to most letter code. Continue. Cool. Let's submit. We're accepted. And comparing to the Java solution, we are a little longer. We actually still using 50 lines. Could we do better? So if this could be removed, right? Yeah, and this could actually be put into this for loop, right? And yeah, code. Okay. This is special case we could remove. Yeah. And the rest actually will be very clear. Let me add more commands. Count each letter. Get the most letter. First put the most letter, and then put the rest letter accordingly. Cool. And yeah, that's all for this one. Hope it helps. See you next time. Bye bye.